Hello there, everyone. Today I thought I'd walk through an Excel example using linear regression. I'll show a few different ways to solve it in Excel. And of course, this is all just leading up to kind of neural networks and how they operate. So without further ado, let's just move over to the Excel video. Bring this up. Here's how the Excel file is formulated. We're going to this tab, V50 example. I'm going to share the linear regression, in a Google Drive so people can access it. Here's a linear regression model. What we have is we have three inputs. So you see X1, X2, and X3 here. We have another column for the intercept, similar to how we've shown in some other videos. We're going to have, these multiple model parameters up here, which we've called theta naught, which is the intercept. And then thetas 1 through 3 are the slope terms that act on inputs 1 through 3. Here's our Y column. So these are our outputs. This is what we want to predict with a model. And we're going to use linear regression to do that. So without further ado, let's go ahead and get into it. The first thing, I'm just going to go through right here. You can skip forward if you need to, but I'm going to name our variables. So I'm going to name that X. I'm going to name these variables theta. I'm actually going to be using another function, and I have to name this X's without that intercept column. And now we're going to name these three, and I'm going to do that, I'm going to go up to this. It's in the Formulas tab, Create from Selection, a real quick way to create, names for variables. So they're all in the top row of my selection. I hit OK, and it's just named all of them. And then I can name this or not name this, but this is cost for the cost function. Okay, so without further ado, let's go ahead and make a linear regression model. So I'm going to start with zeros for initializing our model parameters. Our prediction, if you recall, is going to be matrix multiplication of X comma theta. So that you see how it selected the dynamic arrays to the left and up above. To make this prediction, I hit enter, and it creates a new dynamic array. Of course, all the values are 0. This loss function is going to be equal to y minus y hat squared. So that's going to give us our L2 loss function. And then we're going to go down to the cost function, and we're going to do the average of L, our loss function. So that's going to give us a value that we can optimize over. So really, that's all we need to set up here. So we can go up to Data. You can go over to the Solver tab. Again, this is our optimization tool. Set objectives. So we have the cost function already entered in here. If you need to go and select it, you can go over and select. Of course, it did that. But we're just going to use a variable name. We want to set that cost function to a minimum. We want to do that by changing. Actually, let's go ahead and just type in theta here. We're going to leave the rest of this as is and go ahead and solve. Okay, I'll actually drag this over so you can see it. It found a solution. We want to keep that solver solution. Press OK. So there we go. You can kind of see dynamically there's this plot off to the side. We've included the Y values, so the actual values are the blue diamonds. And then the predictions are in orange here. So that's our model and what it's predicting relative to these other values. What you might notice is, I color-coded theta 1, 2, and 3. Theta 1 has a huge influence. and that's actually the thickness over here variable. So this armor thickness is x1, and that has a big effect. So you can see, how this metric changes as a function of that variable. The fact that it isn't straight just means that these other dimensions or other inputs also have an effect. So there we go. That's just a simple example using an L2 loss function. For the rest of the time, I'm going to show how to directly solve this using matrix multiplication, up above in linear algebra. And then I'm going to show this linear function that comes in Excel that does this all automatically. So, if you just wanted to see an example of how this works, I've done that now, but I'll also do this linear algebra method and the LINEST function down at the bottom. So let's get into the linear algebra method. Here I like to use the let function. So we'll do the let function. And what you have to do for the let function, if we look at this function off to the side, we're going to need x and y. So that's easy, x. And then the second value again is setting x equal to, well, we've already named the variable x in there. We've already named y, y. And then the next value, we can go ahead and do the formula. So what do we do first? Let's do transpose of x. You can see kind of that first term there in the formula. We want to then matrix multiply the transpose of x times x. Okay. The next term is a matrix inverse. So that's M inverse is the function, and we're going to inverse the whole thing. We are then going to matrix multiply by the transpose of x. And then last, we're going to matrix multiply by y. And then we're going to cross our fingers and hit enter, and hopefully it gives us all of these values. Okay, it does. If you see solving this through just linear algebra to the optimization method, it's the exact same values. So we did pretty well with setting up the problem outside of just solving it through this formula. Now the third way that you can do this is through this LINEST function. There's also, I think an intercept and a slope term, but we're going to show how to use this. And so I'm going to go ahead. Actually, I just made it blur everything out. Maybe it's easier to just start over. Yeah, why not? Okay. So when I type in LINEST, you can see down at the bottom here, it's saying, or maybe that doesn't show up on your screen. But the first is the known y's. So you want to select y. The second term is known x's. So that's where I identified just the 3 x inputs. The next is whether or not we have an intercept term. So in this case, that is true. We do have an intercept term. And then the last is whether you want to return all these regression statistics. And we'll just go ahead and enter false for now. Okay, actually, I'm going to go up here, set it to the same number of significant figures. So what you notice right off the bat with this LINEST function is it actually goes in reverse. So you have the intercept as the very last column, and then the first slope acting on the first input is is the third column, the second, the first. If we want to, we can actually flip this. So yeah, why not? Let's go ahead and just paste that term over here. Oh, you can see how it's aligning it this way. So we might want to transpose that so we can see it. Okay, so it's in the exact opposite order of what we have up above. Again, I'm going to go ahead and take this, same sig figs, so it's easier to just compare. So what we want to do here is sort it in the opposite direction. So one of the things we can use is sort by. This array, oh geez, there's a bunch of different ways that we can do this, but how about we sort by, let's do column of X. So that's going to give us the columns for each of the 4 of these. We need to transpose it so that it's in the same shape as those model parameters. And then you see the next term in the sort by is whether you want to sort it ascending or descending. So we want to sort it in descending order, so that it flips everything. And there we go. There's our new, kind of theta parameters here. What I will mention is, okay, so we've taken these, and shown how you obtain the model coefficients. This last one, if we change it to true, it's going to give us all of these statistics, which is these standard errors of the different slope terms. Standard error of the intercept is this first one. I don't like these NAs, so I'm going to actually eliminate them. If I do an if error, it's going to grab those cells, and I just want to set them equal to nothing. So there we go. Now you can kind of see these standard errors, which are for slope 3, 2, 1, and the intercept. Here you have the R squared, so the R squared of this model is 0.99. The standard error of Y, 9.4. This is the F statistic here, the 640, and so that's very high. So you could calculate at a certain confidence limit, like what should the F statistic be, and then here's, again, sum of squares for the regression model and the residuals. So it is describing much of the data, with a little bit of error. So there we go. There's a couple different ways to attack a linear regression model. One of the reasons why I started the way I did using Excel Solver is when we get into regularization, we're going to modify this cost function and add additional terms that penalize these slope terms becoming much too large. And this is how you will regularize your model. And that is not built into like the LINEST function. And so that's in those sort of cases where you want to make sure that you are not overfitting to your data. You're going to want to regularize your model. And in order to do that within Excel, you're going to need to use the solver tool for optimization. So with that, thank you for joining. I think this covered just a good linear regression in Excel, model. And, next I'm going to cover optimization, gradient descent, and logistic regression. Okay. Thanks there. May the course be with you.